Welcome to the Rockwell Collins MultiScan Radar computer-based training program. Let's get started by looking at MultiScan controls and displays. Boeing aircraft are equipped with a split-function control panel, giving the captain and first officer independent control of the radar. The captain's controls are at the top and left, and the first officer's controls are at the bottom and right. Controls that are common to both crew members are in the center of the panel. Auto toggles between the radar's auto and manual modes. When toggled to manual, the letter M is displayed. In manual, the radar works exactly like traditional manual radars. Tilt and gain must be manually controlled by the pilot. Further, with the exception of wind shear, automatic features are disabled. The letter A is displayed next to the tilt code on the ND when in auto. When the radar is in auto and the weather mode is selected, MultiScan's essential automatic weather detection features are activated. When auto and the WX+T mode are selected, essential automatic features and MultiScan ThreatTrack's new threat evaluation features are enabled. On aircraft equipped with dual systems, when the center button is in the out position, the left RT is active. As indicated by the hat symbol on the button, the right RT is active when the button is in. The test button initiates the radar's test function. When test is selected, aircraft that are equipped with the new MultiScan ThreatTrack software will display these predictive overflight icons to the left and right of the wind shear icon. The new capabilities of MultiScan ThreatTrack radar are discussed in detail in Module 3. Transfer allows either pilot to select the other crew member's display settings. For instance, should the captain push his transfer button, the settings selected by the first officer would be displayed on his ND. Weather radar is, of course, all about showing weather. When the radar is in auto and weather is selected, the radar's essential automatic features are activated. MultiScan eliminates the ground clutter and displays the weather out to 320 nautical miles. In these pictures, note the absence of ground clutter and the thunderstorm cells at 60, 130, and 180 nautical miles. In addition, the radar displays a fourth cell that is over the horizon. The yellow arc is a pack alert function. Pack Alert warns crews that the intervening cell is attenuating the radar beam, and the area behind the cell is not visible to the radar. Pack Alert is active only when auto and cal gain are selected. One significant difference between MultiScan in auto and a traditional radar is that weather below the aircraft altitude, or non-threat weather, is not displayed. Also, due to the fact that weather changes rapidly and the radar now has an effective range of 320 nautical miles, it is not unusual to see a complete thunderstorm cycle with mature cells dissipating and new cells appearing on the display as the aircraft moves towards the weather. MultiScan uses the quiet, dark cockpit philosophy. In other words, if the weather is not a threat because it is below the aircraft altitude, it is not displayed. Note the flight path vector on the HUD display, and also note that it is intersecting the 0-degree pitch line, indicating that the aircraft flight path is above these cells. Also note that the display shows a clean screen since the weather is below the aircraft flight altitude. Weather that is below the aircraft altitude is often visible from the cockpit, and there are occasions where it may appear that cells should be displayed, but are not. For instance, this cell is not displayed, but is it at the aircraft altitude? How about now? The fact is that this is a post-convective cell. On close approach, it can be seen that there is no substance to the cell. In fact, you can see right through it. In addition, the cell is 1 to 2,000 feet below the aircraft and thus not a threat. Again, applying the quiet, dark cockpit philosophy, this non-threat cell is not displayed. A quick note on radar beam width. Although a 3-degree radar beam is pretty narrow, the fact is that at 80 nautical miles it is already 25,000 feet in diameter. What this means is that even when the radar uses multiple scans, the height estimation of the cell becomes more and more coarse the further the cell is from the aircraft. So on occasion, weather that is initially visible at longer ranges may fall off the display as it approaches the aircraft, and the radar can better determine the cell heights. Remember that when the radar is in auto and the weather mode is selected, the essential MultiScan automatic features are activated. In weather mode, the radar paints the standard red, yellow, green, and black radar colors. Remember that black is a radar color. Black does not mean that weather is not present, but only that the weather is not reflective enough to meet the green threshold display criteria. For the new MultiScan ThreatTrack radar, WX plus T no longer means weather plus turb, but has been reclassified as weather plus threat. These new ThreatTrack features will be covered in detail in Module 3. Map mode displays all the information that the radar sees, both ground and weather returns. The ground clutter button is similar to map mode, except it is a spring-loaded momentary function. The tilt control is inactive during auto operation. Full above and below the calibrated gain position is available during both manual and auto operation. Calibrated gain is selected when the triangle is at the 12 o'clock position. When the radar is operated in manual and calibrated gain is selected, standard radar reflectivity rain rates are displayed. An increase or decrease of 10 dB of sensitivity represents a change of 1 color level. Increasing the gain to max increases the sensitivity by 16 dB, or an increase of 1.5 color levels. Yellow will display as red and green will display as yellow or red. In addition, areas of black may display as green or yellow. Conversely, selecting minimum gain decreases the sensitivity by 14 dB and reduces the color levels approximately 1.5 times. Thus, green returns and a significant portion of the yellow returns will disappear, and red will turn to yellow or green. Essentially, in min gain, only thunderstorm cores are displayed, and they will be represented as green or yellow. Min gain should be used for momentary weather evaluation only, and then the gain should be returned to the cal gain position in order to avoid underrepresenting the thunderstorm threat. VAR will be displayed on the ND below the tilt code when the gain is in any position other than cal. Now let's explore gain in auto mode. A typical thunderstorm is very reflective below the freezing level. However, the top third of the storm tends to be glaciated and non-reflective. As an aircraft climbs, the radar beam moves higher in the cell, and at cruise altitudes can overscan the reflective portion of the cell, resulting in inadvertent thunderstorm top penetration. In auto mode, MultiScan uses an automatic temperature-based gain to reduce this threat. As the aircraft climbs and the outside air temperature decreases, the radar automatically increases gain to compensate for the lower reflectivity of upper-level thunderstorms. So let's see how this works in actual operating conditions. This example shows a typical low-reflectivity oceanic cell. As mentioned previously, with manual cal gain selected, only the core of the thunderstorm is visible. In manual max gain, the greater extent of the thunderstorm is visible, and the cores are now red. In auto cal gain, the radar has automatically increased the gain as the outside air temperature decreased, providing a picture that is very similar to manual max gain and reducing the threat of inadvertent thunderstorm top penetration. Note that at cruise altitudes, manual max gain and auto cal gain are essentially equivalent. In auto, further increasing the gain above the CAL position may result in overwarning and unnecessary deviations. Rockwell Collins recommends that the radar be operated in auto, CAL gain, and weather plus threat, or WX plus T, in order to gain maximum benefit from MultiScan ThreatTrack's cell evaluation features. In summary, remember that full above and below gain is available during both manual and auto operation. Major differences between operating the radar in manual mode and in auto mode include the following. First, when operating in auto mode, the tilt control is inactive. Second, in auto mode, MultiScan utilizes the quiet, dark cockpit philosophy, and weather that is below the aircraft altitude is not displayed. Third, automatic temperature-based gain increases the gain as the aircraft climbs into colder regions, resulting in a picture that is very similar to manual max gain at cruise altitude. Operation in CAL gain while in auto is recommended. Finally, the recommended operating mode is weather plus threat during all phases of flight.